Okay, number 35 here is asking us to take region B, the lower part of this figure, and revolve it about the line y equals 6. So y equals 6 is already drawn for us. That's this line that's right here. So I'll just kind of extend that right here with a dotted line. And then region B, which of course is this region right here, is going to get revolved. So I'm going to draw the 180. You know what? I got to get rid of the label. That's going to be really messy right there. Okay, so we're going to draw the 180-degree reflection of what this thing is going to look like, which would be that, and then roughly kind of a parabolic curve looking something like that. Okay, guys, so we're now creating this solid right here that's going to look, let's see here, something like that, and that, and then open on the top right here. Okay, so we would see all of that on the left edge, and on the right edge, all the way here on the side, it looks like that thing is going to be a solid circle there like that, although this would be a hidden line. So it's kind of a bowl viewed from the side right there, and something like that. Okay, two questions we got to decide right away. First of all, dx or dy. Anytime that your axis of revolution is horizontal, we cut those slices perpendicular to the axis of revolution. This is a dx problem. Got it. Second thing we need to worry about, discs or washers. Are we flush up against the axis of revolution, or is there a gap? Well, there's a whole bunch of gap right there, guys. This thing's kind of hollow inside. So we're going to be dealing with washers for our cross sections. So let me get started then. Formula for area of a washer is going to be pi times the quantity big R squared minus little r squared. Okay, then let's start working on big R and little r. Both of them start at the axis of revolution. Big R goes through the first curve, and it'll go all the way to the second curve. So what I just drew there in red is big R. And as I'm hoping you guys see, it doesn't matter where we draw this, big R is going to remain constant. There we go. Big R is top curve minus bottom curve. So big R is stopped right here by the line y equals 6 minus this curve right down here, which is the x-axis. That would be y equals 0, so big R is always going to be 6 units long. Little r, though, is going to be more interesting. Little r goes from the axis of revolution and stops when it hits the first curve right there, and little r is going to be variable. It'll be bigger the further left you move it. So how do we measure that vertical variable segment? Top curve minus bottom curve. It is stopped on the top right here by y equals 6 minus it's stopped on the bottom, by the equation I just erased a while ago, which was y equals x squared plus 2. My bad. So the x squared plus 2, I'm going to put in parentheses, guys. Let's not make a silly mistake here by forgetting those, and we're going to distribute the negative here. So little r is going to end up being a 6 minus 2. That'll be a 4 minus x squared. So there's our big R. There's our little r. So back to it now. Area of a washer expressed as a function of x is going to be pi times, in brackets, big R squared. So 6 squared is going to be 36 minus little r, 4 minus x squared. That needs to get squared as well. So there's our expression now for a of x, pi times big R squared minus little r squared. Okay, so with that in mind, that should be the hard part now, guys. Volume will be the definite integral, we said, taken with respect to x of this integrand right here. So I'll put the pi out in front, and again, I'm not pressed for time right now. You guys might just want to write a of x there and not put the pi out in front, but anyway, 36 minus of 4 minus x squared quantity squared. Got it. All we're missing now are limits of integration. Lowest and highest values of x. So this region begins right here at the y-axis where x is 0, and it ends right over here where x is equal to 2. So with that integral, guys, we should be able to type all of that into our calculator in one step and hopefully get the right answer. Now, I'm not going to goof up. When I goof up a lot, I'm not going to forget the pi out in front. So here we go. Pi multiplied by the integral, so menu 43 for you guys, going here from x equals 0 up until x equals 2. Gotcha. And then our integrand right now is going to be big R squared. So that was going to be the 6 squared, which is 36, minus, and then we had in parentheses here the equation of the wait a minute, I'm getting this wrong here. There you go. 4 minus x squared, quantity squared. I could tell I was losing that one there mentally. 4 minus x squared, close the parenthesis, quantity squared. Okay, and we're integrating all of that with respect to x. Before you hit enter, it's probably worth a good look back and forth between your paper and the calculator to make sure that you've got that right. But what do we have here, guys? 824 pi over 15. And looking at the solutions manual, yep, that's exactly the answer that they have there as well. Apparently it doesn't simplify any better than that. So 824 pi over 15, and we'll put a cubic units at the end of that just because it's a volume, even though you don't need to do that. Okay, so that's problem number 35.